Have you ever looked up at the night sky and wondered what stories those faint streaks of light might tell? Some comets blaze so brightly that entire civilizations record their passing, while others drift silently, unseen by human eyes. Today, let's journey together into one of the most extraordinary chapters of comet exploration, the time when humanity sent a fleet of spacecraft to chase down the most famous comet of all, Halley. This is the story of the Halley Armada. Comets have always been mysterious visitors to our skies. Some of them blaze across the heavens in such splendor that entire civilizations take notice. These are the so-called Great Comets, visible to the naked eye and stretching across enormous sections of the night sky. But most comets pass by quietly, hidden from sight, only detected by the steady gaze of telescopes that monitor the darkness above. It is thought that billions of comets exist in our solar system, each following its own lonely path. Astronomers group them by their orbital periods: short period comets reaching only as far as Jupiter, intermediate period comets stretching toward Neptune and the Kuiper belt, and long period comets originating from the distant Oort cloud, taking thousands or even millions of years to return. What makes comets so fascinating is not only their orbits, but also their transformations. As they approach the sun, the frozen material on their surface, water, ice, carbon dioxide and other volatiles, sublimates into space, creating the luminous comas and sweeping tails that have captured human imagination for millennia. It is in these fiery displays that we recognize them, though most will vanish from our skies, never to be seen again in our lifetimes. Among these countless wanderers, one stands apart: Halley's Comet. Unlike the long-period giants we see only once in recorded history, Halley is an intermediate period comet. Its orbit takes roughly 75 years short, enough that one person might see it twice. Records of Halley go back astonishingly far, all the way to 467 BC. Think about that: ancient observers, Roman scholars, medieval chroniclers, and modern astronomers, all gazing at the same comet. In many ways, Halley has been a bridge through time, uniting generations of humanity under a shared cosmic spectacle. With such regularity and brilliance, it was no surprise that as Halley approached in the 1980s, the World Space Agency saw a rare opportunity. For the very first time, humanity would not just watch a comet from Earth, but send probes to meet it up close. And what followed became known as a Halley's Armada. The name Halley's Armada refers to 5 separate spacecraft launched by 3 different space agencies, all converging on Halley in 1986. It was a moment of both competition and cooperation on a global scale. From Europe came Giotto, a daring mission from the European Space Agency. The Soviet Union, together with France, contributed Vega 1 and Vega 2. And from Japan's ISAS, later to be known as JWST, came Suisei and Sakigake, their nation's first steps into deep space. Together, these probes created an unprecedented fleet, each with its own goals and limitations, but united by one target: to uncover the secrets of Halley's nucleus. Let's begin with Vega 1 and 2. Their missions started not with Halley, but with Venus, where they deployed landers and balloons to study the planet's atmosphere. But clever planning allowed them to continue their journeys. Using Venus for a gravity assist, both motherships redirected toward Halley, a maneuver that was crucial because Halley's orbit is far from simple. Its path is highly elliptical, retrograde compared to the planets, and tilted 18 degrees to the solar plane. Reaching it required precision. The twin Vega spacecraft launched just days apart from Kazakhstan and reached Halley in early March 1986, Vega 1 on the 6th and Vega 2 on the 9th. Flying within only 8,000 kilometers, they captured photos of the nucleus, measured its temperature, studied its coma and sampled its dust. But perhaps their most important contribution was not their own data. The positional information they sent back was shared with the Giotto team, allowing ESA to refine its trajectory and risk a far closer flyby. In that sense, the Vegas became the pathfinders for the Armada. Meanwhile, Japan entered the interplanetary stage for the first time. The Sakigake and Suisei probes were not as advanced as their European and Soviet counterparts, but they carried immense symbolic weight. They were demonstrations that Japan could join the community of spacefaring nations. Sakigake launched first carried no camera at all. Instead, it measured magnetic fields and plasma observing space itself. Suisei launched a few months later carried an imaging system and a solar wind detector. While modest in design, Suisei's mission was ambitious to study Halley's vast coma from a distance. On March 8th, Suisei passed Halley at about 150,000 kilometers and continuously imaged its glowing envelope of gas and dust. Even at that distance, the spacecraft was struck by two particles' reminders of how perilous a comet's environment can be. Sakigake, observing from 7 million kilometers away, added complementary data on the larger environment around Halley. Though these missions were less dramatic, they marked Japan's arrival in deep space and contributed valuable insights to the collective story. And then came Giotto. This was ESA's bold leap to approach Halley closer than anyone dared. The plan was to pass within just 600 kilometers of the comet's nucleus, a feat requiring both courage and luck. Scientists worried whether the spacecraft could survive such a hazardous flyby. To improve its chances, Giotto carried a protective shield and tucked its most critical instruments deep within its body. The risk was real at those speeds. Even a speck of dust could cripple the probe. On March 13, 1986, Giotto began its daring approach. It transmitted the first colour images of a comet's nucleus, revealing a world no one had ever seen before. Jagged, irregular, and shrouded in jets of gas, Halley's core emerged from the darkness. But then disaster struck. As the probe drew closest, it was battered by particles. A violent impact sent Giotto spinning, breaking contact with Earth. For 35 agonizing minutes, mission controllers stared at silence. Was the mission lost? Had the spacecraft been destroyed at the very moment of triumph, and then against all expectations, Giotto stabilized itself? Contact was restored. The probe had survived. Its camera was damaged beyond use, but not before capturing the closest images ever seen of a comet's heart. Giotto had become a hero of space exploration, daring and scarred, but victorious. So what did the Armada uncover? The findings reshaped our understanding of comets. First, Halley's nucleus was far darker than expected, darker than coal. The classic idea of a dirty snowball gave way to a new picture: comets as snowy dirt balls with surfaces dominated by dust and only pockets of exposed ice. Surprisingly, only about 10% of Halley's surface was active, with bright jets erupting from localized regions. These plumes released dust and ice into space, feeding the magnificent coma and tail. The dust scattered through the solar system is what we see as meteor showers when Earth crosses a comet's path. Analysis showed that the coma contained water ice, but also carbon dioxide, methane, ammonia, hydrocarbons, iron and sodium. Halley was not a pristine snowball, but a complex, dirty mixture. Perhaps the most startling discovery concerned water itself. For years, scientists thought Earth's oceans might have been delivered by comets. But Halley's water told a different story. Its ratio of deuterium to hydrogen was unlike Earth's oceans, suggesting a different origin. If comets were not the main source, then perhaps asteroids played a greater role in bringing water to our world. Halley also proved to be light and porous, with a density of only about 0.6 grams per cubic centimetre, more like a loose rubble pile than a solid body. Its surface temperatures ranged between 27 and 127 degrees Celsius, depending on exposure to the sun. Altogether, these results painted a picture of comets as fragile, dynamic, and scientifically invaluable relics of the solar system's birth. The Halley Armada was more than just a set of missions. It was a multinational collaboration that transformed a celestial spectacle into a treasure trove of knowledge. For the first time, humanity had looked directly at the nucleus of a comet and discovered a world stranger and darker than anyone had imagined. And yet Halley is not gone forever. Its 75-year journey continues, and it will return in 2061. Perhaps some of us will still be here to witness it. Perhaps today's children will be the ones to look up and see the same comet that inspired civilizations past. What stories will they tell then? Until that day, Halley remains a reminder of what we can achieve when we reach beyond Earth. By uniting telescopes, spacecraft and nations, we took our first true step into understanding these ancient travellers of the solar system. As Halley continues its 75-year journey, it carries with it the echoes of our past encounters. The Armada of 1986 revealed secrets we never expected comets darker, stranger and more complex than we once believed. And yet what we uncovered is only the beginning. When Halley returns in 2061, a new generation will gaze upward, perhaps with technology far beyond ours, and add their own discoveries to this timeless story. Until then, we carry forward both the knowledge and the wonder of that daring multinational mission. So let's keep looking up, because every time a comet streaks across our skies, it reminds us that we are part of a vast and ongoing cosmic story.